So in this discussion, we will see how to identify whether a compound or a molecule is aromatic, anti-aromatic, and non-aromatic. How can we tell, or how can we know whether a given molecule or a compound is aromatic and non-aromatic and anti-aromatic? So each one of these have a set of conditions for you to call it its name. For example, for aromatic compounds, the conditions are: one, that the compound must be acyclic. That means the compound should have a closed rings, closed rings. Condition number two, the compound should, or the molecule should be conjugated. That means the bi-electron should overlap. The bi-electron should overlap so that it forms the localized electron. To form the localized electron. And condition number three is that the compound must be a planar. That means it should have a 2D structure. And condition number four, the compound should not be sp3 hybridized. Should not be sp3 hybridized. Should not be sp3 hybridized. If it is sp3 hybridized, it disturbs the conjugation and the localization of electrons. And lastly, it should conform Huckel's rule. Huckel's rule, which is 4n plus 2. 4n plus 2. So when n is 0, the number of bi-electron is 2. When n is 1, the number of bi-electrons are 6. N is 2, the number of bi-electron is 10, and the list goes like that. So aromatic compound have those conditions: must be cyclic, must be conjugated, must be a planar, should not be sp3 hybridized. That means should either be sp2 or sp hybridized. Huckel's rule, it should conform the Huckel rule, that is 4n plus 2. And the number of bi-electrons is 2, 6, 10, 14, 18, and 22. So if the compound has this number of aromatic bi-electrons, that compound is aromatic, and it has the rest of the conditions. So what about anti-aromatic? Anti-aromatic. So anti-aromatic compounds, the conditions are similar to this, only that the difference is the rule here, where the aromatic compound has 4n plus 2, anti-aromatic compound has 4n rule. So the rest of the conditions are the same. So that means the compound is cyclic. The compound must be conjugated. The compound must be a planar. The compound should not be sp3 hybridized. And Lastly, the only difference now is it conforms the 4n rule, which when n is 1, the pi electron is 4. When n is 2, the pi electron is 8. When n is 3, the pi electron is 12, 16, and the list continues like that. So that is the condition of anti-aromatic compound. The only difference now is it has 4n rule, which gives a pi electron of 4, 8, 12, 16, and 20. So if you see these pi electrons, that means, and the compound has the rest of the conditions, that means the compound or the molecule is anti-aromatic. And what about non-aromatic? So non-aromatic compound, the conditions are compound not cyclic, is the opposite of anti-aromatic and aromatic, compound not conjugated, the compound is not planar, the compound is sp3 hybridized, and the number of pi electrons are odd number. Number of pi electrons are odd number. So you have 3, 5, 7, 9, like that. So if it has those conditions, not cyclic, not conjugated, the compound is not planar, the compound is sp3 hybridized, and it has odd number of pi electrons, so that compound is non-aromatic compounds. So let's see some examples. 1, 2, 3 examples of these. Okay, let's say we have got this structure. Okay, how can we know whether that compound is aromatic, non-aromatic, or anti-aromatic? We'll see the set conditions. So the compound, if you look at the compound is cyclic, and then the compound is conjugated, the compound is planar. That means it is 2D structure. The compound is sp2 hybridized. And lastly, does it conform Huckel's rule? Let us see. If it conforms 4n plus 2, we'll see the pi electrons. There are 3 pi bonds, 1, 2, 3 times 2. There are 6, that means that is 6 pi electrons. So we said if a compound has 2 pi electron, 6 pi electron, 10 pi electrons, 14 pi electrons, 18 pi electrons, the compound is aromatic. So if we look at our compound, we have 3 pi bonds, 1, 2, 3 times 2 electrons each. That means we have 6 pi electrons, and it conforms the Huckel rules so the compound is aromatic. The compound is aromatic compound. Okay, let's say another one. Let's say we have got this structure. Okay, let's say we have got that structure. Okay, can we identify whether the compound is aromatic, non-aromatic, or anti-aromatic? Yes, we can tell by looking the set conditions. Okay, condition number 1, if you look at the structure, it is cyclic, it is planar, it is conjugated, and then it is sp2 hybridized, Does it conform Huckel's rule? Let us see whether it conforms Huckel's rule or it conforms the rule of 4n. How many pi electrons does it have? There are 4 pi bond. 1, 2, 3, 4. That means the compound has 8 pi electrons. So we say if the compound or the molecule has 4 pi electron, 8 pi electron, that is 12 pi electrons, 16 pi electrons, and 20 pi electrons, we say that compound is anti-aromatic. So our compound here has 1, 2, 3, 4 pi bond, which give us 8 pi electrons. So it conforms 4n rule, which means it has 8 pi electron. So the compound is anti-aromatic. The compound is anti-aromatic. The compound is anti-aromatic. And lastly, let us see another example. Let's say we have got this structure. No? Oh, sorry for that. Let me draw well. Let me have like this. Okay, let's say we have got that structure. Can we tell whether the compound is aromatic, anti-aromatic, or non-aromatic? Yes, we can tell by looking at the structure. Let us see. Is the compound cyclic? Yes, the compound is cyclic. It's somehow cyclic. Is it conjugated? Not fully conjugated. Not fully conjugated. And it's not planar. And the compound, if you look at here, the compound is sp3 hybridized. sp3 hybridized. So that means if the compound is sp3 hybridized, the compound is non-aromatic. Non-aromatic compound. So that is how we can identify whether a molecule or compound is aromatic, non-aromatic,